This tutorial is for educational use only. It is not authorized nor approved for any other use.
Hi and welcome. If this is your first time on this channel, I would like to ask you a favor. Hit the thumbs up and subscribe, because I know that you're interested in how to deploy your own algorithmic stablecoin. Well, you come to the right place. Thank you. In this tutorial, we are going to cover from start to finish how to deploy your own algorithmic stablecoin. One thing that I'm going to promise on this tutorial is that your mind is going to start seeing crypto completely different. You are going to start seeing not only the stablecoins, but also the normal day-to-day currency, the currency that we use to do transactions right now, differently. Because now you're going to start asking questions. How are we able to say a dollar it's worth $1? What is backing the value of the US dollar? What is backing the value of the euro? What is backing the value of gold and silver and all that? Because now you know that in order for a coin or a currency to have value, it needs to be backed by something. Okay, so in this particular tutorial, we are going to be building a stable coin that is going to be algorithmic. And we are going to be backing that token with two different asset classes. And we are going to be naming this stablecoin the N2 USD. It's going to be a token that is backed by Tether and also an unstable collateral. The unstable collateral can be Ethereum, can be BNB, it can be Bitcoin, it can be any asset that its price constantly fluctuates. And when we mention algorithmic and when we're specifying that it's algorithmic, it's because of that. It's because the collateral that I'm using to back the value is unstable, but we still have to provide the stable aspect of that token, which means that we need to do some mechanisms to maintain the peg. Maintaining the peg, it's maintaining the value on a one-to-one basis. If we're backing this token against the US dollar, I have to make sure that the value of the token is 1 or at least 0.99 to 1, okay? Which is the value of the US dollar, okay? So, and for that, we're going to be using two different collateral types. The first collateral, we're going to call this collateral A. It's going to be backed by Tether. The second collateral is going to be backed by Ethereum, okay? And we are going to be doing the whole platform. We need to, first of all, hold that collateral somewhere. We need to designate a vault because we're going to be using cryptocurrencies as our collateral. I am going to be building a reserve smart contract, a smart contract that is going to hold that collateral, okay? Which will be used to back the value of the N2 USD. Good so far? Awesome. And this happens not only if we're backing it with a cryptocurrency. Let's say I am going to be using, for example, euros. If I'm going to be using euros, I have to store this. This is called fiat money. It's going to be stored in a vault in usually a financial institution in which I will have to provide access to the information to that vault. I need to somehow tell the exchanges, I need to tell the market that I'm backing that cryptocurrency against a physical collateral that I have stored in the vault, which means that I have to rely on oracles to provide me that price feed or balance feed into the blockchain using proof of reserve. And we're going to be working with that, okay? But in this scenario, we're going to be building a smart contract that is going to hold cryptocurrency, the two collaterals in that contract. And that is the same contract that will be used to query. We're going to be creating an interface that is going to allow access from the outside to read the balances and make sure that we can provide that information. So then we are proving that we have the collateral to back the cryptocurrency that we're going to be building, okay? The N2D USD is going to be an ERC20 token smart contract, just like any other token smart contract. It's going to have an initial supply of 1 million tokens. which means that I have to somehow provide a collateral that is valued at $1 million. We said that we are going to be providing collateral A, which is the stable collateral Tether. Tether, it's a known stablecoin that will be used as collateral A. Check this out. If we provide Tether, we want to tell the smart contract that is going to dictate the algorithmic aspect of this stablecoin, the percentage of the stable reserve and the unstable reserve, okay? In this case, the percentage of Tether and the percentage of Ethereum as our unstable collateral. I am going to be providing 20% of the reserve value in USDT or Tether USD, which means that I have to provide, if we're going to be minting 1 million tokens, that means that we need to provide $1 million in collateral. I need to have 200,000 Tether tokens stored in the reserve vault smart contract. The smart contract that is going to be the brains of the operation, or in this case, the contract that is going to control the algorithmic aspect of the token, is going to be the governance contract. In a nutshell, the governance contract, it's going to burn tokens, it's going to mint tokens, and it's also going to balance to make sure that the value of the stable currency or the stable coin maintain its peg. We're going to be building a function that is going to do the balancing of that value, okay? What does that mean? It means that I have to associate the governance smart contract with the N2 USD token smart contract that will create the supply, which means that governance smart contract is going to control the emission of new N2 USD and the burn of N2 USD existing, okay? As I mentioned, burning and minting, that is one way to maintain the algorithmic aspect of the stable coin. However, it's not the only one, and I'm not going to suggest that that will be the best approach, okay? Burning the stable coin supply to maintain the peg. And don't worry, I'm going to go through this, why it's one way versus the other. I'm going to explain everything, okay? But I will not suggest burning the N2 USD token as means of rebalancing the peg, because if those tokens are already distributed, doing transactions with that token, you have no control of that token, which means that you cannot burn the token, okay? Don't worry, we'll get back to that, okay? So with that said, reserve smart contract, it's going to hold USDT and it's going to hold Ethereum. Okay, so we're going to be dropping ETH into that smart contract as the remaining collateral. We said that we have 20% of USDT as collateral A, and we got 80% as collateral B. And you're just going to say, well, I do know that because it's a 1-to-1 value of Tether against the US dollar. I just need to make sure that I have 200,000 USDT tokens in the vault, in the smart contract, in the reserve. Yes, absolutely. Well, how do we know how much Ethereum or how much ETH do I need to have stored in the vault smart contract to fulfill the other 80%? So then we have the 1-to-1 peg. Let's do a little bit of math, and it's going to be very simple. Trust me. 200,000, we know USDT. That's 20% collateral reserve. We know that we have 200,000 USDT times the price of USDT. It's $1, okay? So we're gonna multiply that. That's gonna give us 200,000, obviously, okay? Now on the right side, this formula, we're going to have the price of ETH. Right now, if we checked the market, it's right around $1,900 per ETH, okay? How much tokens do we need to fulfill the $800,000 remaining collateral that we need to store to give the stable value of 1 to our N2 USD? It's very simple. All we need to do is that we need to grab the price of Ethereum and we're going to divide that by 800,000, which is what we need. There you go. That gives us 421.05 Ethereum. You see, it's not that hard. We grab the current price of Ethereum and we divide that by the amount that we need to fulfill the 80% collateral. That will give us 421.05 ETH tokens that we need in the vault. Beautiful. We just got ourselves the stable value of 1 USD with the N2 USD. Awesome. Hang on. Here comes the fun part. The price of Ethereum just went down. Now it's worth $1,600 5.75. What do we do in that case? We have effectively lost the collateral needed to provide a one-to-one value to the N2 USD. It has dropped in value because the price of ETH has gone down, and ETH is our second collateral. So we need to bring the peg back into equilibrium and to balance so that we can regain the 0.99. First of all, we need to find how much that we lost in collateral. Very simple. We're going to do the same math, but it's going to be opposite. Now that we know how many ETH tokens do we have on the reserve smart contract, we have 421.05. We're going to multiply that by the current price of Ethereum, which in this case is going to be $1,675. That gives us $258.75. We have effectively lost how much? $100,000 before. We're now going to subtract that to 705 to 5875. Now we are left with 905 to 5875. Yikes. So how much is the stable token worth now? Very simple to find out. Let's now divide current collateral value in the reserve against the token supply, which is a 1 million tokens. That gives us 0.91, which means that we have effectively lost the peg status. We have lost the stable status of the token. The token has went down in price. How do we bring back $1 or the 99 cent to $1 peg? The first option that we have is to burn the N2 USD supply. And when you say burn, how are we going to burn? Okay, so here's the thing. The governance smart contract is going to issue the mint action or the execution to mint to the N2 USD token smart contract, which means that the governance smart contract is going to control that function, okay? When the N2 USD performs the mint of that supply gets delivered onto the governance smart contract. So the supply is currently in the governance smart contract. If you did not send those tokens out of the governance smart contract, or at least the entire supply that was minted, you did not withdraw that supply and you started trading the supply and you started selling the tokens, you started doing all the applications that you want to do with that token. If you left some of that supply still held in the governance smart contract, that will allow you to burn because you are in control. You are in possession of that token, which means that you can burn. As long as we have enough coins stored in the governance smart contract that we can burn, and it will satisfy the requirement to bring back the peg. How many tokens do we have to burn in order for us to regain back the peg? In option 1, if the governance smart contract is holding at least 94,741 tokens. If we have that still available in the governance smart contract, we can effectively burn that supply and bring back the peg, because now we have less tokens to provide the value or provide the collateral. Okay, so that's option 1. Option 1, we burn the N2 USD supply. But here's the thing, you're circulating that supply. If it's not in your control, you cannot burn that supply. Okay, which gives us option number 2. I think it's self-explanatory. We have to provide the collateral that we're missing on the reserve smart contract, because now Ethereum is worth 1,675 and not 1,900. I can either drop 94,751 Tether USDT onto the reserve, and that will bring back, because they're a one-to-one value, right? That's option 1. Option number 2 is that we need to find how much ETH do we need to buy or acquire and deposit into the reserve to provide the missing collateral. Okay, let's do some math. Very simple math. What's the simplest way to find how much ETH do we need? The same way we found out how much ETH do we need to begin with. Okay, so in this case is divide the amount that we need to replenish against the current value of ETH. So in this case, ETH is 1,675. That gives us a total of 56.56 Ethereum that we have to provide in the collateral on the vault, on the reserve smart contract. Boom. So we got option number 2 taken care of. We mentioned option 1, burn tokens from the N2 USD supply. Option number 2, provide the extra collateral to back the value so we can bring back the peg to 99 to 1 USD, 0.99 to 1 USD, okay? And there's a third option. In the current algorithmic stablecoins, this usually is the preferred way of doing things. In any blockchain platform, usually there's going to be a token that is called the utility token. It is a token that is used to pay for services on that platform. You know, let's say, for example, Polygon, we have the Matic token. That is their quote utility token. You pay transaction fees using Matic in Polygon. If you're working with Ethereum, pay transaction fees using ETH. In Binance Smart Chain, you pay using BNB and such. So those are utility tokens. So when we deploy an algorithmic stable coin, there's the third option that we can use. Instead of us using Ethereum or any other asset as an asset to back as collateral that is unstable, we can use our own token, our own utility token. And that is the preferred way of usually deploying the algorithmic stablecoin because it gives you more control over the algorithmic stablecoin balancing, right? Put it this way, okay? You know that I usually use the N to the R. This is my fake token. This is the token that we use as demo on this channel. That is the utility token. So with the N to the R token, I can deposit that token as collateral number 2, as the unstable collateral in the reserve vault smart contract, and provide the liquidity necessary to back the value of the algorithmic stablecoin, right? But here's the thing, we need to make sure that we have enough value in the utility token so that we can provide the collateral needed. Because remember, we are providing 80% of the stablecoin value. It's done with collateral B or the unstable token collateral, right? So check this out. Let's say I was backing this collateral, the second collateral. Instead of me using Ethereum, I was using my own N to the R utility token. And I provided as collateral B 10 million of those utility tokens, of those N to the R tokens, okay? At the time when I launched the stable coin, the value of N to the R was 0.08 cents, okay? Which means that every single coin was worth 0.08. If we multiply 0.08 times 10 million, we should get $100,000, which is the collateral needed to satisfy the 100%, okay? The problem is the following. Now we are facing the same issue as we faced with Ethereum. Price went down. Now the N to the R token is worth 0.06, okay? Which means we lost 2 cents on each token as the collateral value. Now that you know that one of the options that we discussed previously is that we can burn the N to USD, that was option number 1. We can burn N to the USD and then provide back, you know, the peg, but we don't necessarily want that because that means that that N to USD needs to be in our control. Okay, but now it's different because now I am in control of the N to the R supply. If we are holding N to the R supply somewhere, not necessarily in the governance smart contract, I don't need to deposit those tokens. I could if I want to. I want to, you know, provide additional liquidity for the stable coin. I can deposit N to the R tokens onto the governance smart contract and decide if I want to burn, okay? Or I want to use that to deposit that onto the reserve. I can do that as well, okay? But not necessarily. So check this out. Now the price of the N to the R token went down by 2 cents. So now it's worth 0.06, okay? That means we lost $200,000 in collateral, in the collateral that is backing the value, okay? What we need to do, we need to determine how much tokens, N to the R tokens, we need to burn. And we are in control of that. If we have enough supply, you know, set aside from the N to the R tokens, we can burn those tokens. We are in control. We cannot burn Ethereum because we're not in control of Ethereum. The only thing we can do if we are holding Ethereum as our second collateral is that we need to provide more, right? But in this case, we are in control of the token, of the N to the R token. So what we need to do, so we need to divide the loss because of that price drop from the collateral, we lost 200,000 against the price of the N to the R token right now, which is 0.06. Okay. By doing that, we are going to end up with 3,333 with 3333. Okay. So we're going to be ending up with that balance, which if we burn that out of my N to the R total or available supply, and we can say that the N to the R token has a billion supply, we burn 3.33 million N to the R tokens. And by doing that, we are effectively raising once again the token value to 0.08. We did not have to touch the reserves. We did not have to burn the N to USD token. All we had to do is work with the utility token. We burned supply out of the utility token. We brought up the price back to 0.08, and the algorithmic stablecoin is back pegged 1-to-1 to the US dollar. Okay, so that is another way. As you start seeing how everything is all fitting together, and now you understand how the value of the algorithmic stablecoin gets pegged and gets maintained, that needs to happen in real time, meaning that I have to be constantly monitoring the value of my collateral. That's the most important thing. The value of my collateral on the market. The moment the unstable, more than anything, because the stable, there's risk. USDT is another collateral that is also peg collateral based, that is pegged 1-to-1. But hey, who knows? If it goes down, you need to make sure that you have a plan to replenish what you lost as the collateral value, so then your token gets back up in the price range, okay, in the stable price. With that said, we need to have a real-time market data feed activity of the token prices. And that value needs to be fed onto the governance smart contract, which means that I have to provide inbound on the governance smart contract. I have to constantly store the value, okay? Well, not constantly. I have to make sure that I have access to that value in real time, okay? Why? Because I am going to be constantly monitoring the value of my collateral. If for some reason Ethereum goes down, or my crypto, or if I decide to use my own utility token, any of the collaterals go down, I need to trigger the rebalancing of the peg. And we're going to be coding. We're going to be creating that function in the governance smart contract. What that's going to do is going to, number one, get the reserve balance, make sure that we have complete read access onto the contract of those reserve tokens, the collateral, get the balance, then calculate based on the price value, how much do we have, and if we are able to balance. If we are not able to provide enough liquidity to back the value, the governance smart contract, it's going to burn the excess tokens, okay? How do we know that? We are going to be providing all that information to the governance smart contract. We are going to be providing the percentage of the collateral that is stable, the percentage that is not stable, not really the percentage of the unstable. We're just going to provide, hey, we have 20% in collateral A, and then we have the rest in the unstable collateral. We're going to make sure that we get the value of both price tokens. Then we're going to do the math to determine if we're still having the 1-to-1 supply, meaning that I have a one collateral, one supply value, or if the supply and the value that I had before is less or more than what is currently in the market, rebalance the peg. Burn tokens on the fly right away. So we're going to do that. We're going to be able to burn tokens, and we're going to be also doing it with the N to USD so that you can see it as well. We can burn the stable tokens as well. And you're going to see that. We're going to do all scenarios. We're going to remove 100,000 USDT from the reserves. Let's just remove that amount. And we should see, because I build the front end, and again, we're going to build all this, you're going to see the price drop. You're going to see the price drop, and it's kind of cool. It's kind of cool, but in reality, it's not. Okay, so you're going to see all that. This is going to be an amazing, amazing tutorial training. We're going to go start to finish. We're going to be building the token smart contract. We're going to be building the governance, the reserve, and we are also going to be interfacing ourselves with Chainlink to retrieve the value of the collateral that we're holding. We're going to be getting those price feeds through Chainlink, because Chainlink is getting those feeds via their oracle. They have a network of oracles that are constantly providing the value of the pairs that we are going to be dealing with. Okay, so that's it for this video. Welcome to this amazing journey in developing and deploying your own algorithmic stablecoin. At the end, we are going to see a fully stable token that at any moment in real time, the price of the collateral goes up and down. We should see the token rebalancing. It should be done automatically. Okay. All right. So that's it for this video. I hope that you enjoy what we are going to be learning together. And if you do me a favor, hit the thumbs up, subscribe if you haven't subscribed to, and we'll see you on the next video. Bye.